Hi guys, Mr. Kerwin here with a nice little video having to do with the first part of the chapter on atoms. This is one of my favorite units in all of chemistry, and this part in particular is one of my favorites just because you get to see the scientific process at work. So we see all these scientists over and over again uh, try to find the correct model of the atom. And so it starts off with talking about the Greek philosopher Democritus and his idea of the atom. You don't really need to know too much about that, but he came up with the word atom, which is from Greek for indivisible. The first modern scientist to talk about the atom was Dalton. And Dalton's theory is listed here on the screen. So, all matter is composed of atoms. Atoms of a given material are identical. Atoms cannot be subdivided, created, or destroyed. Atoms can combine in whole number ratios. And in chemical reactions, atoms are combined, separated, and rearranged. So Dalton came up with this in the early 19th century. And this was the big step forward from just this idea that the atom is just a big cue ball. It kind of sets it here into simple writing. What we know now is a little bit different. Most of that theory is still accepted today, 300 years later, 200 years later. And we do know that we can split the atom. That's what you guys learned about in your last chapter about nuclear chemistry. Not all the atoms of the same element have the same mass. We'll talk more about that in the next video. And in addition, atoms and element can change into different elements in a nuclear reaction. Again, something you guys talked about in your last unit. So we're going to talk about the next big discovery in terms of the atom. In 1897, J.J. Thomson used a cathode ray tube, sometimes called a CRT, to deduce the presence of the electron, the negatively charged subatomic particle. This is kind of a very simple diagram of what that looks like. You have a positive end, you have a negative end. And what they realized is what was basically going through the tube was what we now know as electrons. Cathode rays tubes are very closely related to X-rays or tubes in old computer monitors and televisions. So Thomson's atomic model, he surmised, he thought, that there was a positive pudding and there's electrons all around it. He was an Englishman, so therefore he called it a plum pudding model. I like to say to my students that if he was an American, it would have been called the chocolate chip cookie model because they're just split around the atom kind of at random. That's what he thought. And it would be like a chocolate chip cookie where they're kind of, the chocolate chips are just kind of all around there. So he called it plum pudding because he was an Englishman, and it's the same kind of thing. The plums would be around the pudding in different parts. The next step forward in discovery of the atom came from Ernest Rutherford in 1911. He did something called the gold foil experiment. So you guys learned about alpha particles in the last unit. They're basically helium nuclei, right? So he shot them into a thin sheet of gold foil. Now, what Rutherford thought would happen, and if it was a plum pudding model, they could scatter at random because if they hit the electrons, they would probably bounce back. But what he ended up finding was a little bit different than he expected. He found that most of them were bouncing back, but a lot of them were just scattering. They were just plowing right through the gold molecules. Very few were greatly deflected, which means very few came back at him. So, this was his conclusions. That there is a small, dense, positively charged part of the atom in the middle. It was small because most of those things would pass through. It was dense because most of the mass was measured to be in that area. And it was positively charged because because we know from the cathode ray tube that most of those things would be negative around it. and that the alpha particles that were positive were repelling it. So Rutherford predicted that in the nucleus, it couldn't just be positive. There was a certain amount of weight in there. So it couldn't just be positive. It couldn't just be these protons. There had to be something else in there. He never finished that part of the hypothesis. 30 years later, the neutron was discovered, and it's about the same size as the proton. So it carries the same amount of weight, but has no electric charge. As you see on this table below, the electron, the proton, and a neutron. And I'll go through this part again if we have a little bit of time at the end of the video. So the electron has a -1 charge. One electron does. One proton has a +1 charge, pro like pros and cons. And then a neutron, like neutral, has no charge. The electron and proton, by relative mass, they mean just relative. So the electron and proton are basically similar, very similar in mass. And then the electron is about 1,000th the size of it. The example they usually use is that one electron is about the size of a blueberry, while the rest of the atom is like a football stadium or a massive sports stadium. So here are our models, starting with Democritus in 400 BC, Dalton in 1803, and then in the 20th century, the plum pudding model, the nuclear model, the solar system model, which we'll discuss at another time, and Schrodinger's model. You can kind of see them on the bottom as well. So let's take a moment real quick and talk about the subatomic particles one more time. So Eugene Goldstein found the proton, the individual proton, because we knew it was positive, but he found the actual proton in 1886. Now I listed here small, once again, thinking about how relative it is. Chadwick discovered the neutron in 1932. Again, notice the mass between the neutron and the proton are virtually the same. The electron was discovered by J.J. Thomson in that cathode ray tube. And the mass, as you can see, if you know a little bit about scientific notation, it's about a scale of 10 to the -4th smaller. And they're distributed around the nucleus. We now know that they produce what we call an electron cloud. So there you go. That is the first half of the chapter that takes you from 4.1 to 4.9. Kind of talks about the parts of the atom and the development of the atom model. It's kind of an essentials look, so I would recommend that you take a look at other resources to get a fuller picture. But this should give you an idea of the main concepts behind it.